Hello! In this video, we will solve the logarithmic equation log base 2 of x plus 3 minus log base 2 of x minus 1 equals log base 2 of x plus 4 minus log base 2 of x plus 2. As you see, on each side of this equation, we have a difference of two logarithms. Therefore, we will start by using the quotient rule to condense these logarithms on each side. This rule tells us that if we have a difference of two logarithms, log base b of x minus log base b of y, then we can condense this into a single logarithm by dividing x by y. Then we can rewrite the left side of this equation as log base 2 of x plus 3 divided by x minus 1. If we apply the same rule on the right side, then we will have log base 2 of x plus 4 over x plus 2. Now, once we have a logarithm on each side, in the next step we will apply the one-to-one property. Here to the right, this property tells us that if log base b of x equals log base b of y, then x equals y. So if the logarithms on each side have the same base, then we can write that x plus 3 over x minus 1 equals x plus 4 over x plus 2. So again, according to this property, x plus 3 over x minus 1 equals x plus 4 over x plus 2. Now from here to solve for x, we can use cross multiplying. We will write that x plus 3 times x plus 2 equals x plus 4 times x minus 1. If we use FOIL on each side, we will get that x squared plus 2x plus 3x plus 6 equals x squared minus x plus 4x and minus 4. When we combine like terms on each side, we get x squared plus 5x plus 6 equals x squared plus 3x minus 4. Now notice that each side has x squared, therefore we will cancel it. And now we have 5x plus 6 equals 3x minus 4. If we subtract 3x from both sides and then 6 from both sides, we will have 5x minus 3x equals negative 4 minus 6. Then on the left side we have 2x, and on the right side negative 10. And now if we divide both sides by 2, then we will get that x equals negative 5. So we found x, but now we have one more important thing to do. We know that in a logarithm, the base has to be positive and not equal to 1, and the expression under the logarithm has to be positive. Therefore, because of these conditions, we have to check our result in the initial equation. If we replace x with negative 5, then all these expressions become negative. For example, negative 5 plus 3 is negative 2, negative 5 minus 1 is negative 6, negative 5 plus 4 is negative 1, and negative 5 plus 2 is negative 3. If at least one of these expressions becomes negative, then this number is not a solution to the given equation. Then we can say that this equation has no solution. Thank you for watching.